embarrassing. You know, stuff you get to that's all. The door. What are you doing back here?
Oh, just came to say hello. Tell you something about your prisms.
Well, what about them?
Well, aren't you going to invite me in?
Invite you in? No more privacy than a goldfish. All right, come in, but you can't stay long.
Can he come in too?
Can who come in?
Jimmy Bean.
Hello.
Okay, here's the idea. The universe is full of cymatic geometric refraction, shapely waves of energetic matter dancing. Okay, I'll do you one weirder. The universe is the cymatic geometric refraction of an integral refractive substrate lattice. It's the crystalline epitaxy of self-organized vortex structures of diamagnetic piezoelectric oscillating resonators. Maybe. And it sparkles.
That's a no. Okay. Because I already see that it's not random. Don't jump to conclusions. Why isn't it random?
Hold on to your density ducks, because we're about to get caught up.
Did you see anything while I was dancing?
Just once, but I don't think you expected him to lift you so high.
I envision it as if the stars were the twinkling spots where the lattice intersects within a crystal. It's descriptive of the underlying structure, and it's pretty. But how can we see it? How do we know? And why should we care?
One imagination at a time, free from the influence of another. Boring. Don't shoot the messenger, babe.
Crystalline substrate epitaxy. The substrate is the material that's spread underneath. Ether, maybe? The epitaxy is the arrangement upon said substrate, the intersecting lattice formation caused by the arrangement of planes under, within, and upon this substrate epitaxy is crystalline, as it has the structure and form of a crystal. The term used for these humongous intersecting planes is galactic sheets or great walls. They are the largest known structures in the cosmos and are often responsible for the honeycomb appearance of the cosmic web. The ancients described it as weaving. All across the ancient world, weaving goddesses spun the threads of fate, time, matter, everything. Some Native American stories tell of a giant spider mother who sits in the center of our galaxy, she who creates from a central source. It is said she weaves a web that connects everything and everyone, and one day she will pull all of creation back to her source.
Who is it?
Don't panic.
Harry?
What?
Can we panic now?
Well, thank you. We'll just go.
It's kind of scary if you think about it. What's more unnerving is that this interconnecting web is said to be coming out of the constellation Scorpio. Scorpions don't spin webs, but the galactic center of our neighborhood is in the sign of Sagittarius at 26 degrees, and Scorpio is right next to Sagittarius. It's as if Grandma is sitting in her old Galactic Center rocker, knitting a trail of scarves that trail out into the area next to her. So they have the general area correct. I could go on and on about this, and I'm sure sometimes I do, and I probably will more in the future, maybe even to you guys. But for now, how'd they know that?
If the nobles find out who you are, there'll be the devil to pay.
And pray that they don't.
The web is organized in a fashion called crystallographic balance. This means that a grid pattern is created by repeating elements of equal weight throughout.
You have been weighed, you have been measured, and you have been found wanting.
Something else that we must keep in mind is that balance doesn't always imply symmetry. As a matter of fact, it rarely does. Think of a pound of lead and a pound of feathers. The weight is the same and evenly distributed, but the mass, size, and makeup is different. Even nothing can be balanced by something if the mass and action of an object cancel out its weight. Empty space is something. Positive space can't even exist without the negative space to hold it, and vice versa. For how do we even know it's negative space without a positive element to contrast? And even though crystals imply a symmetry in some way, they can build their plane faces in such arrangements that the overall body becomes asymmetric. Think of Jackson Pollock, the king of crystallographic balance. The composition is balanced and yet without the confines of exact symmetry, just like the cosmos. Nature does this a lot. Now picture this crystallography in a three-dimensional space. All kinds of weird things start to happen. Geo.umass.edu says in regards to the crystal symmetry, while all mere planes and poles of rotation must intersect at one point, this point may not be in the center of symmetry.
You don't believe what you read in the newspapers, especially the Mirror.
So there's that too. And with this kind of balance and structure, the possibilities for shape forming within the lattice matrix are infinite.
Jacquard loom, Joseph Jacquard lived in France, and he developed this technology in 1801. So here we've got basically the same very heavy beam construction loom, but we don't have those wooden frames, and we don't have the associated pedals to raise and lower the threads. Instead, we're going to use the punch cards that are going to be read by a mechanism upstairs that has pins coming out of it. So the weaver's going to be over here by the front of the loom, by the window, and as he steps on that pedal, that causes these threads to raise, and you can see he's got shuttles for the left and right thread, so he's going to throw one of the shuttles through. Then he's going to release that heavy pedal, and that rope on the back is going to mechanically ratchet these cards up and press them into that series of pins that's up in the machine. We really can't see it too well right now. But the pins are attached to metal rods that are coming down. If you stand over here, too, you can see them pretty well. And the metal rods are attached to the strings, and the strings are attached to these weighted eyelet pieces, and all of our threads are threaded through there. So now as he's weaving, and these are pressed into the pins one at a time, when a pin goes through a hole, that allows that rod that's attached to the pin to lift. Lifts the string and lifts your associated thread. When there is no hole, like in these blank areas, the pin doesn't move and the thread doesn't move. So this is giving direction one at a time to the threads, and you can do very, very fancy pieces of weaving. So this is an example of a jacquard piece. So if you want to do curved lines and curlicues and manipulate one thread at a time to do the lettering, this is the kind of machine that you need. So what Joseph Jacquard developed here in 1801 is our first computer program. So you may have, many of the people that come through here recognize the computer punch cards, and IBM does give credit to Jacquard. They studied
do they? Okay.
They studied his system as they came up with these, because basically binary code here is either the thread is up or it's not. So 1801 is when Jacquard loom was developed.
Is that it? Is that all you got?
Kind of like the holes punched in a loom card, the patterns form a net, and we are caught inside. Each thread is laced through, and the strings are layered and interwoven until it becomes a gigantic, multi-dimensional tapestry. And then, as the waves bump into the little bumps that have collected along the strings, they ring and sing like a bump on a music box cylinder. It vibrates. The acoustic, mechanical, and plasma frequencies that intersect cause ripples, waves, eddies, and tides. These energy waves include all frequencies of the electromagnetic spectrum, EMF. The patterns created by these intersecting waves generate geometric and organic shapes. This is known as cymatics. Put it all together, and the universe can be described as a crystalline substrate epitaxy of cymatic geometric refraction. Super simple, right? It really is a matrix, and everything is just kind of floating in it, suspended in motion. But something has to hold it all together. There's some sort of shared conduit throughout the entirety of the universe that has yet to be adequately identified. That would be the strings. And we're pretty sure it's plasma. Some of those plasmas grow bright and hot, clearly visible in the spectrums of light. If they were people, they might be the preps, the jocks, the politicians, the popular kids. Everyone can see them. We're familiar with their names and expect certain things from them. They can make it seem to the whole world that they are the only spectrums that exist. Matter, shine. Other plasma frequencies are in dark mode. We can't see them. They may not want to be seen. They may be slower, a bit chiller, less excited, and hanging out low-key, trying to remain invisible. Don't tell the boss he's here kind of thing. Maybe, whatever. I don't really care. I won't tell. Go on with your bad self, dark mode plasma. Party incognito. Then again, they might be so fast, we didn't even know they've hit us until they're gone. Some of them, like radio waves, may just want to be heard. Some waves might want to pass straight through matter, tearing and ripping its atoms apart. How do we know who's who? Is it the waves themselves or the frequency of their travel? Is it their personality or their circumstance that directs their behavior? Is it who, what, how they are? Can they change? Whether we can see it or not, it is there, like a string of pearls dotting the night sky. And those strings are very important. They're filaments with pinch points. They deliver everything from solid matter to molecular particles, energy and information, and everything is attached. Even you. You're a pearl. You're a star.
Mother of pearl!
Pinch poke Yomi a Coke Jinx. Now I can't talk till someone says your name. I don't even know your name. It might be a while. Okay. That's mean. You can talk. Like filaments, we should always maintain membranes and boundaries. It's a polite way to self-organize. Because likes like. Elements naturally segregate into like energetic states. It happens at parties too. The wikis say, a pinch is the compression of an electrically conducting filament by magnetic forces. The conductor is usually a plasma, but could also be a solid or liquid metal. Pinches were the first type of device used for nuclear fusion. Since stars are at specific pinch points, they're viewed as energy centers, where the compression of the electrically conducting filament is compressed by magnetic forces. Well, clearly they're energy centers, but why? And what do they do besides shine? I think that might be beyond my pay grade, but there are some very smart people who have been looking into it with some very tangible results. In this theory, the sun is an anode delivering energy to its own private circuit. our solar system. Others agree that the whole of it is a functional circuit, but assign the sun as a cathode. Like I said, above my pay grade. But I have my ideas. And it's interesting to me because if this was the case, each body, i.e. planet, moon, asteroid, etc., would also have to have a role in the function of the larger machine. This is presently difficult to assign as we are still learning about our own planet and are being surprised by each new data set that comes in from our investigative excursions to our neighboring celestial bodies. All of our parts are for something. Nature's pretty clever that way. There's a reason for every part, a purpose to be served. We just don't always know what that is. In the electric universe theory, the Earth is viewed as a capacitor, as it has the physical properties capable of storing an electric charge. That's a short and skinny of it. It's much more complicated than that, maybe for another day. But this explanation is kind of weird to me, as a capacitor must have a pair or more of conductive plates separated by a dielectric insulator. So the terminals would be the poles and the insulator would be... what? How is it dielectrically insulated?
Well, you're right, but for the wrong reason. Sounds logical, doesn't it?
Yeah.
Well, that's wrong. Wrong.
It's wrong? Wrong.
Wrong.
That's right.
Not right.
That's how I was wrong?
That's how you were wrong. What did he say?
He said he's incapable of making a mistake, therefore I must be wrong.
Just because we have a strong electric presence doesn't necessarily mean that Earth is storing it. On the contrary, we only keep what we need. I have a really hard time with this one, so I tried to think of what other mechanism in a circuit would best describe the actions of function Earth takes on, and how do those attributes inform a function beneficial to the overall machine of the solar system. It could be a number of things. Let's try this one. See what you think. Earth can be described as a piezoelectric oscillating crystal resonator with the land to insulate and the salt water to conduct. Superficially at least. Up to 72% of the Earth is surface water. 96% of that water is salinated, salt water. The salt in the water is made up of chlorine and sodium ions. They're ionic because they have either lost or gained an electron, so they are free to accelerate in an electric field. And boy, do they. You can even light up a light bulb with salt water and vinegar. You might try it later. Mind your manners and your safety. Quartz makes up 20% of the Earth's crust and 12% of the land surface. Quartz has piezoelectric quality that makes it ideal material for oscillating resonators. It is able to maintain frequency stability of very high vibrations at a precise consistency. And there's also something interesting about the silicate content of the surface. Silica is translucent and keeps very little of the light pass through it. It is often used for waveguides and fiber optic transmission lines. Mica is a silicate mineral that is smooth and shiny and found in scales in crystals, granite, and other rocks. It, too, is a crystal. Mica can be used for electrical and thermal insulators. It's starting to get pretty weird.
That's an even worse idea than all the other bad ones you had today.
What's interesting is thinking of it as a tube coil resonator. Maybe the Earth has a cylindrical center. It makes me think of the mechanics a lot more plausible than a sphere because we have poles and they spin around an axis on a tilt in a wobbly way as it travels in an elliptical orbit around the sun. And even that orbit has inclination and declination wobble that is similar to the rings around a tube coil resonator. So again, the pattern of motion repeats. Like bobbins on a sewing machine passing over the shuttle of a loom, these intersecting lines of travel weave filaments into the known universe, and maybe beyond. Are we unknowingly witnessing the Earth's digestion of cosmic energy via the piezoelectric resonance oscillations? Is it eating, breathing, metabolizing the charge? And are the magnetic properties of our planet's layered spheres what keeps us in our position in the great web of things? How much deeper does it go? We aren't exactly sure. A new hypothesis was just introduced by physicist Eugene Bagashoff, proposing that the interior of the Earth is actually made up of huge populations of microorganisms that electrically feed themselves off the telluric currents within the planet. Thermophiles. Would you call me? You're a thermophile.
Termites, huh?
That's what my husband thought.
And he's an expert in these matters.
Well, no.
Didn't think so.
Super interesting. Might change everything we know. The earth itself might be alive. As someone who uses microbial inoculants in gardening, this idea was very intriguing to me. As a matter of fact, the specific endomycorrhizal fungi I use is Rhizophagus intraradices. Rhizo for the roots, intraradices because the spore grows into colonies radially, eventually webbing a sponge within the soil that does all kinds of cool things for the garden. Could it be that there's a gigantic microbial web beneath our feet? Could the currents that flow beneath and through our planet being respirated by a planetary scale subsurface microcosm? Do they enjoy listening to the spirits sing? Does it make them salivate like Pavlov's dogs, causing the ground to shake above them? Are the patterns repeating within the structure and the function of the earth itself? We'll talk about that later more, I promise. Crystals within crystals, webs within webs, fed by electric charge and shaped by magnetic force. The universal constants may be more than equations. They might be structural patterns as well. Is this sacred geometry? Platonic solids? The Fibonacci sequence? What happens if it becomes unraveled? Tube coil around a resonator, a capacitor, a pinch point at the crux of many converging lines on a plane, in a field, crystalline substrate epitaxy. What does any of this have to do with spiders?
Dance off, bro! Me and you!
It's a matter of webbing, per se, or weaving. Sometimes it's weaving, sometimes it's strings. Strings playing harmonic chords, melodic transitions, a symphony of refracted light, and other stuff. I call it the choir of angles. On a two-dimensional plane, a circle is made up of 360 degrees. That's one vector for every degree outward from the center radially. Enter the third dimension, and that circle becomes a sphere. It now has 41,253 degrees squared. Multiply that by the number of intersecting spheres. That's a lot of vectors, Victor.
Flight 209er, you are cleared for takeoff.
Roger. Huh?
LA departure frequency 123.9er.
Roger. Huh? Request vector. Over. What?
Flight 209er, clear for vector 324.
We have clearance, Clarence. Roger, Roger. What's our vector, Victor?
Howard radio clearance, over.
That's Clarence, over. Over.
Roger.
Huh?
Roger, over.
What? Huh?
Who?
Where the hell are we?
Geographically speaking, in the northern hemisphere, socially on the margins, and narratively with some way to go.
It's a pattern that does repeat. But from our limited perspective, it can be difficult to tell if the lines are coming or going. It's difficult to see even how far away things actually are. There's a lot of visual tricks our eyes can play, and we can't really get off this big floating ball to get a better look. So all the lines we can draw must be traced from where we are standing. It's super inconvenient, but it is what it is. To resolve this, a method called parallax was introduced. I like this idea because it reminds me of perspective drawing techniques, and I thought, oh, okay, 3 converging lines, and then formulate for distance. Wait till we're on the other side of the sun, apply formula, and calculate again. Makes sense, right? Except for the unmentioned factors of dust, debris, and questionable wave interference that might change the frequency of the light, i.e. color or polarity. And to be fair, parallax comes from the 16th century French word parallaxe, which at the time meant fact of seeing wrongly.
Perhaps you should read the instructions first.
And even deeper from the Greek word parallaxis, a change. This etymology can either be encouraging or discouraging, depending on how we change our minds. And what about foreshortening? Foreshortening is a perspective effect used by artists to give the implication that something is closer than it is by portraying said object as very detailed in the foreground and then strongly receding into the background. This can be done with both directional lines and light and color shifts. The object can have the illusion of being compressed, making it appear shorter than it really is. But this is how we translate such three-dimensional visualizations into a two-dimensional setting. It is what makes the illusion believable. It is also a technique that makes me question the distances calculated by parallax because of our view. It is hard to determine the level of foreshortening and therefore the true size, shape, and distance of cosmic objects. Unless, of course, there's another way to determine these things.
Don't you know anything about refracted light there, boy?
It's the sunlight coming through.
I'll do the explaining if you don't mind, little Miss Know-It-All. Now, boy, you see here Don't they ever cut your hair in that darn orphanage?
I like it the way it is.
Look at you. So much hair, you look like you're wearing a coonskin cap.
Let me go, will ya? Anyway, about the refracted light.
Oh, yes. Now, pay attention, boy. You see the shape of this crystal? That is a prism. The light is stripped by that angle. That refracts the ray, splits the colors, diffuses them at an oblique angle, and bends it out into a dispersed color band. You understand?
What he means is, the sun comes through here and paints a rainbow, you see? Oh, I understand. Can I try it once, please?
Go ahead, but don't break anything.
One fish, two fish, redshift, blue shift. According to the Encyclopedia Britannica, redshift is defined as displacement of the spectrum of an astronomical object toward longer red wavelengths. It is generally attributed to the Doppler effect, which is a change in a wavelength that results when a given source of waves and an observer are in rapid motion with respect to one another. As you could imagine, blue shift is the displacement results of the spectrum of an object towards shorter blue wavelengths. And fish swim in the sea, which reminds me of attenuation, which is the reduction of the amplitude of a signal, electric current, or other oscillation. Attenuation is the gradual loss of flux through a medium. Water and air will both attenuate sunlight. That's why the sky and oceans are blue, and why I question the simple mechanical properties of redshift, blue shift. If we're going to use artist methods of point perspectives to calculate the distance between objects in a grid matrix, we must also consider the crap in the way that could distort the perception of said distance. In art, we call it atmospheric perspective. The effect of this is the loss of detail and contrast as the background moves further away from the viewer. The more ambient particulate there is in the atmosphere between object and viewer, the more distance is perceived between the two. In a space free of particulate, dust, humidity, outside light interference, etc., the objects can seem closer together. Without the ability to change our point of view, where we're standing, and with all of these complicating factors, it becomes almost impossible to say exactly how far away a star might be from us. Not to mention the idea of lensing. If the universe is a crystalline substrate epitaxy, we have to consider a few things about the way light and other EMF waves interact with crystals. They oscillate quite quickly, and they have a prismatic effect of breaking the waves down into smaller constituent properties. This is called refraction. Minerva.union.edu defines refraction as the bending of light rays as they pass from one medium to another. This is due to the change in the speed of light or differential index of refraction as it passes across a plane boundary. And you thought the speed of light was a constant, didn't you? But it's the color. That's the speed. And then, of course, there's also diffraction, which is the bending of the light around obstacles and into shadow regions due to the wave nature of the light. This causes alternating regions of dark and light, referred to as fringes. Crystals are capable of changing the polarization of the waves that pass through them, and in this way are considered birefringence materials. They kind of clean up the refractive index mess within the fringes. Because of this, they make amazing optical lenses. We talked about this already in the video Light the Fused, but a few more details to bring it to speed here. A lens is a transparent molded or ground material that can refract light in such a way that an image is formed. Some are thick in the center and thin around the edges, giving them a convex surface. When the light is passed through convex lenses, the rays of light are converged into a single point. Some lenses are thinner in the center and wider around the edges. This concave shape spreads the light from a single point into many diverging points. Both types can be thought of as previously being part of a sphere. Hey, the Earth is a sphere, and only about half of it's lit up at a time. It's something to think about.
What is divine light?
What time is it?
Aziz, light! Much better, thank you, Aziz.
That's a weak hypothesis.
Do you ever think before you speak?
No, I just whip it out there.
That actually makes sense.
Okay, you have some skill.
You can disagree with me, but the bottom line is, if these problems were concretely resolved, scientists from all over the world wouldn't still be working on it, and would probably have hopefully by now moved on to bigger, better things. But alas, there is much particulate in the atmosphere of discussion regarding this subject. This refractive diffracting lensing is significant in that it shapes the cosmic EMF often emitted off or from spherical structures, but not always. But as far as I can see, stars are round. So are the planets and moons. But a sphere isn't the only roundish shape that the objects of the cosmos come in. They also come in conical, toroidal, spiral, cylindrical, lobed, double-lobed, and the ever-fashionable fluffy cloud motif, which I think looks great on nebulae, don't you?
I request the cone of silence.
And even though clouds look randomly fluffy, there is a rotating cyclical structure churning and turning to produce them, whether it's visible to us or not. It's kind of strange to think of a bunch of giant spiders weaving webs of plasma filaments that sing all across space, but it does look that way if you think about it. The giant web part, I mean, not so sure about the spiders. But when we look at the patterns of converging lines, they do form a substance similar to a spider's web, a tapestry, a crystal, and just as diverse in structure and texture. It's starting to make more sense why the ancients would tell stories about the web of the universal filaments this way. There's a functional versatility in seeing it from this perspective as well. If you are trying to recall an observation and convey that observation to another person who hasn't seen it, the most effective way would be describing it in relation to something the other person was already familiar with. And doing that also allows a connection to be made about the behaviors repeated throughout the universe. Spiders might mimic the structure of the galaxies in their webs. We humans might weave a loom. Line after line of twisted fibers intertwined to construct shapes repeated in strings that connect all things.
Let's see what we got up here. Oh my God, they got the professor.
I do say that all seemed rather rehearsed.
That was the most extraordinary thing I have seen in my entire life.
Well, hello, beautiful.
Nowhere on the shore is the relation of a creature to its surroundings a matter of single cause and effect. Each living thing is bound to its world by many threads, weaving the intricate design of fabric of life. Nature uses only the longest threads to weave her patterns, so that each small piece of her fabric reveals the organization of the entire tapestry. Weave beautifully your small thread in the grand tapestry. He who is false to the present duty breaks a thread in the loom, and you will see the effect when the weave of lifetime is unraveled. I assure you that there's a lot involved in compositions with figures. It's just like weaving. You must control and keep an eye on several things at once. We give the function to the winds and slumber tranquilly in the present, weaving the dull world around us into dreams. It's the moon that makes it so still, weaving some mystery. In the silence, there's eloquence. Stop weaving and see how the patterns improve.